Okay, I think we should get started. Yesterday, so last week's session, we started going over lists, and then we saw how we'd use the slice operator so that we can adapt the lists. We saw about the index positions being negative. What would that do? And then we started looking at tuples and how they're different from lists. And then we stopped here. But I'm going to go back and recap a little bit of the basics of lists, just to make sure you guys are confident and you're able to get everything. So a list in Python is a grouping of multiple data elements in an order. So whenever we want something in an order, then we use the list. And when we use a list, it can have multiple data elements. It can have numeric elements, like it can have integers, decimals, it can have strings, and strings as numbers. It can have any other types. You can also have like complex things such as tuples that we got introduced last week. You can actually have a tuple as a part of a list as well. So that can be part of a list as well. So when you print the type of A, it shows that it's a class list. So just to reiterate another thing, everything, whether it's an integer type, whether it's a string type, everything in Python is a class. So those are all the basic data types are also listed as classes in Python. And the first thing we do about lists is we know it's an ordered element and it's a zero indexed element. So all these positions have an index number, and the first position is going to be 0, then 1, 2, 3, 4, 5, 6, and so on. So this, if we print the length of the class, so a dot or you can use, I'm sorry, len of a, that actually prints the length of the array or list. So in this case, I assigned a is 1 to 5, so it took the length as 5. And as we talk about the reference by value, even though there are 5 elements, the indexing starts at 0. So a of 4 would actually represent the last element. A of 0 would represent the first element for a 5 element array. So we see that. And last week we also saw about how do we slice. So slice is taking a part of this ordered list, and if we want to take a part of this and then just store that in a different variable or use that for a different purpose, then that part of the array starting at one position and ending in another position is a slice. And how Python and many other languages do slices, I was learning Scala, and I learned that like even in Scala, the slicing operator is done in a similar logic. So the first position is the starting position, and the last position is the ending position, but we exclude it. So for example, if you want the first to second position, we actually give the first position, which is a 0, and then we want the 0th element, the first element. So we actually say give me starting 2. So what that will do is anything before 2, that is 0 and 1, it will actually slice out. Or if you want the second element, then you say from index 1, and if you want it until the fourth element, then 0, 1, 2, 3, 4 um, would be the fifth element's index. So you put in 4 there, and that will provide everything from the first element until the fourth element. Okay, so we covered this last time, but a couple of things as well. When we use the index, when we don't provide the starting index, then it takes it from the beginning, and if we don't provide the ending index, it goes until the end. So if you want everything from the third index number 3 position, then you give 3 colon, that means 3 index position would be 4, and everything until the end is 4 and 5. If you say everything from index position 1, then you will get 2 until 5.
இந்த காட்டுது
Hey
சார்.
Karthi, can you hear me? Hey Karthi, I can hear you now. I'm going to mute you. Yeah, sorry.
Sir, your workplace did not display, sir. Your voice only hear it.
You cannot see my screen?
Yes, sir.
Yeah, Anand, we don't see your screen.
Oh, I'm sorry, you should have told me. Okay, so it's better.
Visible, sir.
Yeah, so what I covered is I just recapped whatever we did last time, Prem, so you should be aware. And for Karthi, we are covering, this is the third session, and we are covering lists. So this is what I showed you at earlier. So it's everything has a class list, and when we use a length, then it actually prints out the length. To get things by reference, we use the index number, and the index number starts at 0. So here, if you want to see 5 elements, then the index element of this is going to be 0. The index element of this is going to be 1. The index element of this is going to be 2, 3, and 4. So the index elements, the index numbers are going to be different from the position numbers, and it's going to be, this is called 0 index. That means the index starts at 0. And the slicing operator that I just spoke about, we slice. When we slice, we get a portion of the element. If you want the first element until the like the first indexed element, which is the second position, until the end, then we give 1 semicolon, and we don't give the end position. That means we get everything. And the important thing to remember about slicing is the first portion is inclusive, that is, get everything from that position onwards, and the second position is exclusive, so it excludes that completely out. Okay. One important thing to understand is we don't get an out of range exception when we go for a slice. Say, for example, here I have 9 elements in A, and if I want to print the 17th element or the 18th element until the 20th element, it doesn't find anything, but it doesn't throw an error. So it just provides an empty array. Or if, for example, I want to provide everything from the third element, or the third element here would be, the third index element here would be 4, and then at the end index I'm saying 20, even though there are not 20 index elements. I'm just saying 20. Then it will still provide me all the elements from 4 onwards, even though the 20 was not even a valid index. So it wouldn't throw an error. So that's something you need to understand and remember. We won't get an index out of range exception for a slice, even though like if I reference the element and say give me the index element of 23 or 18, like we did last time, I would immediately get a index list out of range exception. So index error, list out of range. Okay. So we also saw about negative positioning. When we use negative positions, so we'll have to count from the back. So the second, like -2 means the second last element. So this is the second last element. And in the starting position, I'm saying second last element, and the end position, I'm not saying anything. That means it will get me everything from the second last position until the end. So I will get 8 and 9. Similarly, if I say like -7 until the 7th index position, that means the -7th index would be, so let me show it here. So the -7 would be the 7th last position. That would mean 1, 2, 3, 4, 5, 6, 7. So that means here. And here I'm going to say the 7th index. And we are going to exclude that position. So what will happen is this is the 0 index, 1, 2, 3, 4, 5, 6, 7. So this position is that, but it will exclude this. So we'll get only the values 3 until 7. Does that make sense? Okay. So I think we covered this this concept last time. So I'm going to go on to cover one more portion here. So now what if we use -5, which is the 5th last position, until the -1, which is the last position or the first last position, and this portion is excluded. So what will happen? So from here, like the 5th last position is here, 5, 1, 2, 3, 4, 5. And the first last position is here, but this is excluded. So we'll get the values 5 until 8. Does that make sense? Okay. And if we interchange these two positions, if we say give me everything from the first last position, that is from here until here, Python thinks that doesn't make sense, because if you start here, you can't go back, and then that would mean Python would return an empty array or an empty list. Okay. So as we go into advanced concepts, you will definitely going to be asked about mutability. So I'm going to introduce the concept here, but we will revisit it as we get to the advanced levels after week 7. So until week 6, we're going to cover the basics. Week 7 onwards, we'll go into advanced concepts. At that time, we'll go back and revisit the mutability. But at this point, it's good for you to understand what mutability is. So mutability would mean that I can actually go into the list and change the element 3, which is index 2. I can change it to be something else. Mutability means I would be allowed to change a list. So the list, Python allows me to change a list. And when we change this, Python edits it in the memory location, like as we covered in class number 1 and 2. When we store a list in the memory, Python allocates a memory location for the list, and all these information in the list is stored together in the same memory location, one after the other, but in the same memory location. All the elements of the list members are stored in that list, and it's assigned the class list for that position. When we actually change a value from the second index, that is this number gets changed from 3 to 4544. At that time, what happens is, in the memory, in the same location, we don't throw that location off and create it in another place. In the same location, we are able to edit the third element or the second index element to be a different number. And we are also able to append items to the list and say add 10. We are able to like insert elements on the list. We are able to delete or pop elements from the list, remove it, reverse it, and after we do all that, what happened is, when we appended 10, we got a 10 here. When we inserted a 3, we got a 3 here. And when we reversed it, it became 10 backwards until 1. And we are also able to delete elements. I don't know if that will work. Let me try that. So I was able to delete the third last item by using the delete item method, and then that brought it back to 10 to 1 in the reverse order. So all these operations are done by Python in memory in the same place, so in the same location. So that concept is called mutability. So there are some elements that are mutable and some that are not mutable. So the ones that are mutable, like list is one of them, like tuple is one that's immutable, so you cannot actually change the values in there. So we'll go and check that out next. So as we talk about that different concept, we'll go to Python tuple. So what happens in a tuple is that, just like lists, the tuples are ordered. They are unmutable, that is, you cannot change the values in them. They're heterogeneous, that is, you can have a number, you can have a text, you can have a number and a text, you can have a number and a text in a list, which an example is here. You can have all those things. It can also contain duplicates. So even though it's ordered, you can have like 1 1 1 1 1 3 4 4 1 1 1. You can have duplicates. that is opposite to a set. Set cannot have duplicates, or a dictionary cannot have the key value as duplicate. So those are the concepts of tuple. So these are data structures we use when we actually code in Python. Let me ask you guys. So Prem, like till now, were you able to follow? Like, can you tell me what is the difference between a list and a tuple?
So list is changeable, sir.
Okay.
We with the memory location we can change,
Yep, that's true.
but tuple means we can't change it.
Okay, it can't change. So that is immutable. Okay, tuple is immutable. Tell me something that's common between those two. Like, what is similar between tuple and list? So the order. So the list and the tuple are both ordered.
Okay, sir.
That means, like, you can say that. Can you give me the fifth element, or the fifth element will be something, and the fifth element will mean something. So it's not like uh, it's not like a bag of marbles. It's more like a order of cards, or a order of uh, arrangements, right? So it's more of how the things are ordered. So say for example, if you want to know what are all the colors that you like, then red, blue, green, that is just a set of colors. So you store that in a set. But if you want to store the three colors in order in which you like it, so the most liked color will be red, then green, then blue. So you store it in that order. Then if order matters, then you store it in a list or a tuple. So that's what the that major difference is. Okay, so that's good. Okay, so Karthi, how comfortably are you with Python until now? Like, do you use Python? Do you know what uh, I'm talking about till now?
Yes, I comfortable.
Okay, you're comfortable until now. Okay,
Yeah.
let me continue. So the next one is tuple. So we have a string of elements in order. So Chicago, then Riyadh, then New Delhi. That's a string tuple. Mixed tuple type has a string, then a integer, then a float, then a list inside it. That whole thing is a tuple. And if I want to print this list, then I go here and say 1, 0, 1, 2, 3. If I want to print that, then I give print of tuple of 3, then I get that list back. If I want to print just the second element from there, then I give print of tuple of 3 of 1. So that just prints that element 78, and it doesn't have any square brackets because it's just that integer that it pulls out. So that's how you reference tuples, just like earlier. Here, if you want to print string tuple of 2, that will print the last city in this list, which is New Delhi. That gets printed here. Okay. You can also create a tuple using a tuple constructor. So if you say create a tuple of Georgia, or say I have a list, right? So I can make a list. So I have a list A here. I can convert that to a tuple by saying sample tuple 2 is equal to tuple of A. I can also have a list uh, created like that by using the list command. Just like we have a tuple command to construct it, we also have a list command. We can have a list and say yeah 2 4. I think that will not work. I'll have to first make a tuple out of it and then do it. So what this did was we had a list A that got converted into a tuple. So if you see the normal braces, you know that that's a tuple. And this one I had a tuple India 2 and 4, or I take this sample tuple and I put it there, and then when I convert it to a list, it converts that into a list. So this was a tuple earlier with normal braces. Now it became a list. And the biggest difference is that like one is mutable, the other is not mutable. And it'll be useful when we go in and try to determine which kind of data element we'll use, which kind of data structure we'll use for the type of operation we do. So if we have a list of the rank of all the students in the class, and if throughout the program we're not going to change the rank of the people or add more people, delete people from that, then we use a tuple. Say we have that list, and every time we do an operation on the program, something is going to change. Either the order of people are going to change, or like more people are going to get added, some people are going to get deleted. Any kind of operation we're going to do, then we use a list. So the difference is, when we use it in the program, do we expect it to change values, or do we expect it to stay the same throughout the program? So that's the decision where we choose which data structure to use. Okay, so here, like list, we went and like changed the values of an element in list. We cannot do that in a tuple because tuples are immutable. So tuple object does not support item assignment, so we cannot do that. Similarly, we did some append operations. So here, when we check what are the available functions that are there, you don't see append there. You see count, which kind of gives you number of elements. You can use equal to. You can get item. You can get the third element. You can find the length. There is something called reversed, but it doesn't reverse the tuple in memory. It reverses it, and then it gives you another value. So if you use reversed, and then if I print sample tuple, I'm still going to have the same order. For easy understanding, I'm just going to make sample tuple as 1 2 3 4 5, and use the normal brackets, remember, for tuple. So when I use the reversed condition, and then I print the sample tuple, Okay, so this error is coming here and it's not proceeding after that. So I should put this in a separate area. Okay, let's start from here. So sample tuple does not have an attribute reversed. I'm sorry, let me do this. So when I use the reversed function, I print back the old value. I still get 1, 2, 3, 4, 5. We'll go back and see what we did for a list. We used the reverse function, not the reversed function. So if you look at this, I did not assign, like I just did a dot reverse. And when I printed a, it reversed the elements completely. But there is no reverse function in tuple. There's only a reversed function. And that's a different function because it doesn't actually reverse the elements in sample tuple. Remember, it's immutable, so it doesn't actually reverse it there. But if I want to like reverse it, I think if I print it, it gives me a reversed object here, and I can go into the object, and whenever I pull one element, it will pull me from 5, then 4, then 3, then 2, then 1. So it does it differently. So the reversed, like in position, it does not reverse it. There's no reverse function, and the reversed one gives you an object which you can use to get like the values. I think we haven't gone into a little bit of detail, but let's try this. For I in reversed tuple, print I. Let's see what that does. So now when I go check if there are any elements, the first one it gives me is a 5. Next one it gives me is a 4, then a 3, then a 2, then a 1. So it gives it out, but tuple does not change in memory. So this position within sample tuple, we don't have any changes. Though we talk about immutability, let's not confuse that with this element will always remain the same throughout the program. We can actually reassign the whole thing. Even though I cannot say sample tuple of 2 is going to be something else, is going to be A. I cannot do this, but you can completely reassign the whole value of sample tuple 2 to be a different value. And in this case, when we print it, we actually get the new value. And in this case, we still say that sample tuple 2 is immutable. And the reason here is, what happened here is, when we reassign, Python assigns a new memory location. For sample tuple 2. So here, say if the memory location earlier was X ABCD 1 2 3 4, now it gives another location Y ABCD 9 7 8 6. So it gives a completely different memory location, and in that location we have this stored, and the previous location is not going to be used anymore. So some other memory program can use that, or if any other program is running on your computer, that can use that. So that gets that memory address location is no longer assigned to a variable. So in essence, what it does is, this tuple location, it was not changed in place, but rather we threw that out and we did a new assignment. So this is actually a reassignment. It's not mutable. So it's still not mutable. So this can be a confusing question that comes in interviews. So if it's mutable, then how can you actually reassign it? So they'll ask you the same concept in different ways, but as long as you understand the concept that you can actually reassign, but you cannot edit the elements in place. When you reassign, it actually assigns a new memory location. So like we saw earlier, list we can append items. In tuple, there is no way to append items. So there's no append um, concept. Similarly, there's a delete item, but you cannot delete items here. There is no delete. So if you see, this is a delete attribute, but no delete item. So there's no delete item here. So you cannot delete items from the two. Okay, we saw two data structures. So data structures are very important for any kind of Python programming. So what happens is when we program, when we write a program, we have to choose what the right data structure is for the problem we're trying to solve. Earlier we saw about an example of your favorite colors, where it can be red, blue, and green. So if I want to say my favorite colors are red, blue, and green, then I put them in curly braces and say it's red, blue, and green. So if so what happens here is, here it's not ordered. So in this case, if somebody else comes and says my favorite colors are blue, green, and red, it's actually blue, green, and red. So the order is changed. In this scenario, both are the same. Like this favorite colors, which has red, blue, and green, and my favorite colors, which has blue, red, green, and red, are the same. But in a tuple and in a list, because it's ordered, the order matters. You actually those two things would be completely different. Like if there's a list with these three elements in this order, and if there's another list with these three elements in this order, both will be different in a list or a tuple. But in a set, these two are exactly the same. Let's check if favorite colors equal to my favorite colors. So here, if I like, even though the order changed, the list of elements are same. We actually get the the equality of these two. So Python thinks these two are exactly the equivalent things. What if I add, somebody says blue twice. So they say my favorite colors are blue, green, red, and blue. So they knew those are their favorite colors, but they didn't realize they repeated it twice. So if that is the case, if I ask Python to check if these two are the same, Python still thinks they are same. And the reason is, when I print my favorite colors, so remember when I assigned, I had 4 elements to it. Now when I run this, Python removed like one of the colors, and it still does not even have the, like, it, we started with blue, then green, and then red, but it stores it in its memory as blue, red, and green. So it doesn't even like care about the order you provide. for instance, let me try printing this as well. I'm going to try printing favorite colors. So if when I entered it, I said it's red, blue, and green in that order, but Python stores it as blue, green, and red. So and when you check these two, Python thinks these two are equivalent. And even if there was a duplicate element, Python just removed the duplicate and just kept the unique items. So those are the concepts of set. So the concepts of set are, it does not allow duplicate elements. So if here I give 1, 2, 2, 3, 3, 3, what would be the value of print A? So Karthi, can you tell me what will be the value of print A? Are you able to get off mute and tell me what will print? Hey Prem, can you try? What will be the value of print A?
So 1, 2, 3.
Okay, yeah, like 1, 2, 3. Sometimes the order may be different, but yeah, it will just have the values 1, 2, 3. Thanks.
Okay, sir. Okay, sir.
So if I because the location does not matter, the order does not matter, a set would not make sense when you say give me the position number 1. We get an error saying set object is not subscriptable, and it's understandable. Python does not keep these in order, or Python does not necessarily know the order of these. It doesn't have an index position for these, unlike a list or a tuple. And let's try create a set using the set method. So just like we had a list method and a tuple method, we also have a set method, and we can give in a list or a tuple, and then we can store that elements into a my set. That's what we're doing here. So when you give set of this list, let me do it in 2 steps so that kind of L1 is equal to this. So Python looks at this, and then it assigns the value L1 a list. So it becomes the class, the type of L1 becomes class, and class list, and then it stores this element. So here if you see there's 50, 40, 30, 20, and 10, but the 20 repeats twice, 30 repeats twice, 40 repeats twice, and 50 repeats twice. So it has it in that way. In list it matters where the position is, but when I make a set of that list, it obviously removes the duplicates, and then it has only the non-duplicate elements, and obviously the order does not matter, so it gives me the unique elements, but yeah, the order is probably different from what we gave it in. So here I have 2 functions, add and remove. So I'm going to try that, and I'm going to add the value 300, and I'm going to remove the value 50, and then I'm going to print it right after that. So here, if you don't understand this print statement, all it does is whatever is within this curly braces, this format, like, so this is a string. Anything that starts in double quotes and ends in double quotes is a string, and I'm using dot, which means I'm with this string I'm calling this format method, and this format method within brackets, whatever is there, is what I'm passing to this format method, and I'm passing the value my set. So in my set, I'll put this element here. Like the format, what it does is it finds the curly braces and puts the my set element inside the replacing the curly braces. So it will put my set here. So it will print like after adding 300, and then it will put the values of my set here. So that's what it'll do. But yeah, this is just a method that we use to do a lot of like substituting inside strings, right? So for that we'll use this method a lot. But yeah, if you don't fully understand that, for now what we need to understand is this curly braces will be replaced by whatever we give inside this. Sometimes we also give two elements, but yeah, for now we're giving one element and then we're going to replace this here. So in this we're doing two things. We are adding an element and then removing an element. So after adding, we get a 300 in the list, but we have 6 elements, and then we remove 50, and then we have 5 elements, but the 50 is gone. So it has 10, 20, 30, 40, 300. So Karthi, like with this, right? Can you tell me if a set is mutable or immutable? You can take a guess. It has to be one or the other, right? Prem, can you try?
So it's mutable.
Yeah, definitely mutable. And the reason is we are able to add elements. We are able to add elements, remove elements. So when we see these methods, when we see add, remove, append, anything like that, then it's definitely it's definitely okay. So it's definitely that piece. Okay, the next one we're going to look at is dictionary, and in dictionary what we see is we see key value pairs. So what is a key value pair is, let me give you an easier example. So when you want to say like there are students and you want that marks, and they scored a certain amount of marks in their test. Say the first student is like the first student's roll number is 1 and he scored a 95, and the second student's roll number is 2 and he scored a 90, and the third student's roll number is 3 and he scored a 100, and the fourth student's roll number is 4 and he scored a like 85. So this, what happens is we have a key, that is we have the roll number as a key and their marks as a value. So we have a pair where we say that okay, if you want to look up, we have, say we have a million elements in this and we want to say, can you check up uh, the student number 500,000 or 5 lakh, student whose roll number is 5 lakh, can you find his mark, right? So if you want to use that kind of functionality, so you want to look up something quickly and you have a large list of elements, in this example you're just going to do 4 elements, but if you want to use that, in that scenario dictionary comes into use very much. So the dictionaries are ones where we will be able to figure out if if you give me a key, this will be the value. So whenever you want to find that out, uh, the data element is used for key value pairs. So whenever we want to use that, we can do that. In this case, we cannot have duplicates. We cannot say like again if I say the first element scored a 75, that would not get stored correctly in Python. So when I actually print it, I'll be missing the values. So student, so here what happened is I lost the value 195. I only have the value 175. So there cannot be duplicates in the keys. So you can, two people can get the same score of 90, or two people can get the same score of uh, say everybody gets 90, right? So that can be possible, but there's no possibility that the keys can be duplicated. So when I print this out, I still lose the element 1 that is 90, and I get the 1 that is 75, which is the last element that I had. That value gets stored. We can have the values the same, but we cannot have duplicate keys. So that's another thing you have to remember. No duplicate keys. Values can be duplicate. If duplicate, the last element remains. Okay, that doesn't format well, but yeah, I'll fix that later. Like earlier, we can also have like when we had student marks, we had everything as to be integers. Here we can have the key to be an integer, the value to be a string. Here the key itself is a string, value is also a string. Here the key is again an integer, but the value is actually a list. And within the list, I have multiple different values. I can have that way as well. So it's a heterogeneous way of storing stuff. The whole thing has a class dictionary. So it's called dict in Python. So we can have the whole thing as a dict. And we can also access, okay, I have that example here, so I'm not going to go through that. So we can access the value. So I want the value 1, or say I want to access the value 2 as a string. So here, this is not a position here. So this is not an index position. So I'm not, even here the order does not matter. So here if I instead of giving 190, 290, if I had said 4321, it still wouldn't make a difference. So even here, so here the position does not matter in a dictionary. What essentially matters is what key value are we referencing. So here one of the key values is 1. The other key value is a string 2. So if I can position the value string 2, then I can get that out. So if you see, for 1 it's a value, and for 2 it says value 2, and I get that value out. So here there is no index position. So that's another thing. I'm going to make a note here. There's no index position here. No index position. Values are returned based on key. So here when we return it, we actually use the key number here, not the index number, and then we return the value. Okay, so that gets us to the end of session 3. I will, any questions as of now? Hey Karthi, Prem, how are you doing?
No question, sir.
Okay, I will send you an assignment. This time it's going to be slightly difficult than week 1 and week 2. So if you have any questions, get back to me by Tuesday or Wednesday. Like try it out. If you're stuck, if you're not able to do the assignment, message me, and then we'll talk about it. I'll try to help you out, and then we'll try
Okay, sir.
to like work on that assignment. Like, and then I'll check out your work,
Okay.
and then we can that'll help you get better. Okay.
Okay, sir.
Okay. That's it, right? Okay, I'm going to stop the session. Okay. Thank you.
Okay.